Hi everyone, today we are going to focus on adding and subtracting fractions. So first let's look at an example of adding and subtracting fractions that have common denominators. The first thing you're going to do is follow the operation that's given to you by adding or subtracting your numerators. Then you are going to keep your common denominator the same. Then whatever your result is, you need to check to see if it can be simplified any further in order to get your final answer. Let's look at these two examples. They're the same problem except one is addition and one is subtraction. So in number 1, we have 1 divided by 2 plus 5 divided by 2. Here we have that common denominator of 2. So we need to keep that in mind. First, we are going to add our numerators. So we have 1 plus 5. Well, 1 plus 5 is going to give us a result of 6. And then we are keeping the common denominator of 2. So right now we have gotten the answer 6 divided by 2. Now we have to simplify this further. You can look at this as simply a division problem and say, okay, well, I know that 6 divided by 2 is 3. Or another way you could think about reducing this is what number goes both into 2 and into 6? That would be 2. So 2 goes into 6 3 times. 2 goes into itself 1 time. So we get 3 divided by 1, and 3 divided by 1 is going to give us our answer of 3. Now let's look at the subtraction problem. Again, we have 1 divided by 2 minus 5 divided by 2. We still have that common denominator of 2. So we need to keep that in mind again. Now we're going to subtract our numerators. So in this case, we have 1 minus 5. Well, 1 minus 5 is going to give us a result of negative 4 in our numerator, and we're keeping our denominator of positive 2. Now we have negative 4 divided by 2, which again, we can simply say that I know that negative 4 divided by 2 is going to give me a result of negative 2. Or I can look at it as 2 goes into both numbers evenly. So 2 goes into itself 1 time, and 2 goes into negative 4 negative 2 times. Negative 2 divided by 1 is going to give us our result of negative 2. Either way works. Now let's review our least common multiple. This is commonly referred to as the LCM. Our LCM is the smallest number that is a multiple of 2 or more numbers. So let's do an example with the numbers 3 and 5. So let's list our multiples of 3. So when you're listing your multiples, you're simply just multiplying by 3. So we have 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. I'm going to stop there. We could continue to go on for a very long time, but we're looking for the smallest number that they have in common. So now I'm going to go ahead and I'm going to list my multiples of 5. So now we're going to count by 5 instead. So we have 5, 10, 15, 20, 25, and 30. I'm going to stop here because already I see that I have 30 in common. But I want the least, the smallest number that they have in common. So in order to do that, here we have 3, 6. So far we don't have a 3 or a 6 in our 5. Then we have a 9. For the 5s, we go to 10, 12, 15. Oh, wait a second. I have a 15 here and a 15 here. So that 15 is my least common multiple between these two. So my LCM is 15. We're going to use that in order to help us add and subtract fractions that have uncommon denominators. So the first thing we need to do is find our least common denominator. Okay, so you're finding the least common multiple of your two denominators. Then you have to multiply your fractions accordingly in order to get the common denominator. And then you have to do whatever you do to the top, you must do to the bottom in order to keep the ratio the same of your fraction. Then you apply the same rules you did for adding and subtracting with a common denominator. You add your numerators and keep your common denominator and always simplify your answer. So let's take a look at the first problem here. We have 1 divided by 4 plus 5 divided by 2. So the first thing we need to do is we need to get at our common denominator. So we're looking at the numbers 4 and 2. So if I'm looking at the numbers 4 and 2, I'm going to start listing my multiples of 2. So we have 2, 4, 6, 8, and 10. And then I'm going to list my multiples of 4. We have 4, 8, oops, not 18, I'm sorry. About to do it again. 8, 12, 16. I think I can stop there for now because I see my least common multiple, which in this case is 4. So my least common multiple already is a denominator in the first problem. So because of that, I don't need to change my first problem. So I'm going to bring down my 1/4 and keep it the same. However, I need to make this 2 become a 4. So in order to get the 2 to be a 4, I'm going to multiply that denominator by 2. But in order to keep my ratio the same, I need to also multiply by my numerator by 2. So now we are applying our multiplying fractions rule. So now we have 5 times by 2, which gives me 10. And then we have 2 times by 2, which gives me that common denominator of 4. Now I have my common denominators. So now we can add numerator to numerator and keep our denominators. So we have 1 plus 10, which is going to give me 11. And we keep our common denominator of 4. And we check to see if we can simplify any further. In this case, we cannot. Now, before I move forward, I want to explain why multiplying by 2 divided by 2 is a legal move. Okay, and I say that lightly because it is allowed in math. The reason that this is allowed is because if you think about 2 divided by 2 as a fraction, if you were to simplify that, it simplifies to be 1. Well, anything multiplied by 1 is itself. So when we multiplied 2 divided by 2, this is like multiplying 5 over 2 by 1. We just changed it to an unsimplified fraction. If we had 10 divided by 4, which was our result from this, we would simplify that and get 5 divided by 2. So we just kind of made it an unsimplified fraction in order to be able to work with it. So just wanted to go over that part with you. Let's continue. Now let's subtract our fractions with unlike denominators. So here we have 1 divided by 4 minus 5 divided by 2. So again, we have our uncommon denominators 4 and 2. Well, we just listed them in the last problem, so we don't need to list our multiples all over again. We know that our LCM is 4. So again, I'm going to keep my 1/4. Oops. Going to keep my 1/4 as my first fraction because it already has the common denominator. And now we have to multiply again by 2 over 2, which again, 2 divided by 2 is like multiplying by 1. Okay, 5 times by 2, or negative 5 times by 2, depending on how you want to view this, is 10, or negative 10. There's my negative, it's already there. Divided by 2 times 2, which is 4. So now we have 1 minus 10, which gives us a result of negative 9, divided by, keep our common denominator of 4. Again, this cannot be simplified any further, so negative 9 divided by 4 is my answer here. At this time, with example number 3, I recommend taking a moment to try this problem on your own. Apply what we've learned, and then unpause it when you've finished and check your answer with ours. So, in example number 3, we have 4 divided by 6 minus 1 divided by 12. So we need to find a least common multiple between 6 and 12. So my multiples of 6, okay, okay, well, I listed my multiples of 6, and I already noticed I have 12 here, but that's my multiple here. So I realize I don't even need to list my multiples of 12 because my least common multiple is 12. So in this case, I can bring down my 1 over 12 to keep that. I'm going to keep my subtraction sign. However, we still have to modify 4 divided by 6. So in order to get 6 to be equal to 12, we have to multiply that by 2. And again, what you do to the denominator, you do to the numerator. Okay, and again, 2 divided by 2 is 1, which is why that rule works. So 2 times 4 gives us a numerator of 8. 2 times 6 gives us a denominator of 12, and we now have common denominators. So 8 minus 1 is 7 divided by 12. Again, we cannot simplify here, so we have our final answer. Moving on to example number 4, okay? In this case, you have to multiply both fractions. We have 2 divided by 7 plus 1 divided by 4. So in this case, you have to multiply both fractions to get your common denominator. So in this case, our common denominator is 28. Now, the way we get 28 is by multiplying 7 by 4, and we get 4 times by 7. Again, we have to multiply our numerators the same, so this becomes 4 in this numerator, and we're going to multiply 1/4 by 7 over 7. So now we're going to look at this as one step at a time, so I'm going to focus on this problem here. So we have 4 times by 2, which is 8, and 4 times by 7, which is 28. We're going to bring down our plus sign. And now we are going to focus on the second part of this, which is 1 times by 7, which is 7, divided by 7 times 4, which is 28. And we now have a common denominator. Add straight across. 8 plus 7 is 15. And 28 is our denominator. Check to see if you can simplify, and in this case, you cannot. So we have 15 divided by 28. Now, one thing that's really important is to understand why this common denominator model actually works. So we have this problem here, 1/4 plus 2/3. So I'm going to draw an imagery of this problem. So let's start with 1/4. Let's do this. Okay, so if I draw a box to my best of my ability, and I break this box down into 4 equal parts. Okay, if this box is made up of 4 equal parts and I only have 1/4, well, 1/4 means I would shade in this area. And now I have 1/4. Now I'm going to add 2/3. So again, I'm going to sketch this in. And this time I'm going to break my box down into 3 equal parts, and I'm going to shade 2/3 of that box. I'm going to redraw that black line in for you. Okay, make it a little easier for you to see the 2/3 drawn out. So now what I need to do is I need to break this up into common pieces. So in order to really see how much of my region is shaded, I need to break my box down into a common amount of pieces. So in order to get my common denominator, we have the numbers 4 and 3. So this means I'm going to multiply by 3/3 by 1/4 and get 3 times 1 is 3. 3 times 4 is 12. Then we have 2 divided by 3. So we're going to multiply this by 4/4. Well, 2 times 4 is 8. 3 times 4 is 12. So this common denominator that we've just been talking about, if it's 12, I'm going to actually break my boxes down and combine. Let's break this into my section of thirds. So notice my green lines mimic this. And now I'm going to break this side down into 4s. So I now have each part of my 12. So now we have 3 out of 12 boxes covered. And here we have our 8 out of 12 boxes shaded. So if we were to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's 11 out of 12 total boxes shaded. And that's our answer. And you would get the same thing. 3 plus 8 is 11, and we keep our common denominator. So that's how you would model with area models. And that's everything for today in adding and subtracting fractions.